Hello everyone. Today let me introduce to you two kinds of clamp meters used in electrical measurements, the standard clamp meter and the specialized AC power clamp meter. On the right side here I have the Fluke 324 and the Amprobe HD14 Pro clamp meters. These are generally referred to as standard or conventional clamp meters. On the left side I have here the specialized AC power clamp meters. This is the Hioki CM3286-01 and the Kyoritsu KEW2062BT. All four of them are true RMS clamp meters. In this video, I will make an overview of their main differences. Most of you may already be familiar with standard clamp meters like this Fluke 324 and Amprobe HD14 Pro. These are just a sampling since you will find many other kinds from different manufacturers. These are excellent test equipment and are staples of electrical practitioners because of their usability in electrical inspections and maintenance. For instance, you can use it like a multimeter to measure AC and DC voltage, resistance and continuity. Its most distinguishing ability is its ability to measure AC current by safely clamping on the conductor to be tested using its JAWS or current sensors. In the case of the Fluke 324, it can also test for temperature. You can see many of the same functionalities in the Amprobe HD14 Pro, including capacitance measurement, but with the addition of frequency measurement in AC voltage. I won't go into an in-depth discussion of their functions, as I have separate videos for each of these, which have a bit more detail that I linked below. The other set of clamp meters, the Hioki CM3286-01 and the KEW2062BT, physically look the same, but they are not your standard clamp meters. Instead, they are specialized AC clamp power meters. Let's take a look at their functions. You will notice that they don't have a DC voltage function, just AC voltage and AC current. Also, you won't find resistance and continuity. What you will find here is their ability to measure AC power, that is, real power in kilowatts, reactive power in kVAR, and power factor. They can provide this in either single-phase or three-phase, balanced or unbalanced. They can also detect phase sequence of a three-phase voltage source as well. Let's make a simple AC voltage measurement. To do this, the procedure is the same with the standard clamp meter. Just turn the function selector to AC voltage. Connect the test leads to the test points. Here I have a reading of 237.4 volts at 60 Hz with peak at 317 volts. To measure AC current, remove the test leads and select the AC current test function. To measure power, you need access to the voltage supply for the voltage probes and access also to the conductor or cable for the current sensor to clamp on simultaneously. Let's take a simple single-phase load to demonstrate the power monitoring of the Hioki CM3286-01. The load will be connected here for its voltage source, and the current sensor will be clamped on one of these cables. Take note that this is just a simple simulation. In practical situations, this outlet here could actually be a panel board or a big circuit breaker, and instead of using the needle tip voltage probes, you could actually use instead alligator clips. Here is my setup for single-phase power measurement using the Hioki CM3286-01. It is giving a reading of 1.17 kilowatts of real power at 0.804 power factor to 35.4 volts AC, 6.2 amperes AC. Apparent power of 1.45 kVA, reactive power of 0.86 kVAR, power factor of 0.808, an angular displacement between voltage and current at 23 degrees, and back again to the default display of 1.17 kilowatts real power at 0.81 power factor. Here is my setup for the Kiritou KEW2062BT for measurement of single-phase power. It is registering 1.17 kilowatts at 0.812 power factor. There is a 33 degrees angular displacement between voltage and current. The apparent power at 1.46 kVA, reactive power at 0.84 kVAR, 234 volts AC and 6.2 amperes AC. And back to 0.814 power factor at 1.17 kilowatts of real power. These two AC power clamp meters produced nearly or practically identical results. There's a slight difference, but the results are well within acceptable range between the two instruments. One of the limitations of these clamp meters is in the inherent design of their jaws, and it applies not just for the standard clamp meters, but also for the specialized AC power clamp meters. While the jaws facilitates easy and safe measurement of current, the size of the jaws may not always allow it to work in tight and confined spaces. In conductors and cables installed very close to each other, the jaws may not be able to fit. This is one of the main reasons why thin jaw design clamp meters are desirable, like this one, the Hioki CM3289, and especially if it can accommodate flexible current sensors like this Hioki CT6280 flexible current sensor, as it allows the sensor to be clamped or to be wrapped in tight locations or in any kind of bundles of cables, regardless of their shape and size, so long as they would fit within the circumference of this flexible current sensor. Now, this one in particular is capable of measuring up to 4,200 amperes of current. So that's all for now, guys. Just a quick overview of the main differences between the standard clamp meter and the specialized AC power clamp meters. As I mentioned earlier, I linked the individual videos of each of these clamp meters below for a little bit more coverage of their functions. My video of the Hioki CM3286 is one of my earlier attempts, so it may not be as polished as the others. I hope you understand. Thank you always for your support. Stay safe.